Okay, I'm starting to install the heads. First, I install the guide bushings. Who remembers when disassembling the pistons had a flat bottom, the combustion chambers? Now you can see these pistons have a pin that is a deflector. Let me explain. Those pistons are the old model, still the original Mercedes ones. They don't make these anymore. By this number, this is the type of piston that comes up. That is, as far as we remember, in the 8th cylinder there was exactly this kind of piston with a divider, but it was just installed incorrectly. When it was replaced, apparently they checked by this number, and the piston was the one that was supposed to be there. But the point is that they all have to be the same. You can't have, let's say, half of the pistons like this and half with a divider. That's the point I wanted to emphasize and explain, just in case someone has a question about it. Depending on the type of bolt, so for example I have bolts here. So I do it in 3 steps and then I turn it with a wrench by 90 degrees. Usually I tighten it to 20 kilograms, then turn it with a wrench by 90 degrees. Normally we need 200 Newton meters, so I set it to 20 kilograms. So we see 20 and 0, 20 kilograms. We see that the head is tightened to 20 kilograms. Now I take a marker and make marks across, I make marks across. Now my task is to turn each bolt 90 degrees. That is, right now I have a mark across, I need to make it along. So that means this head is tightened for me with him. All the marks are now along the engine. Well, and so on, I tighten all the other heads. That's it. The main work is done. The hardest part, so to speak. Now that means I'll be installing the injectors, the pump, adjusting the valves, and so on. Next, I'll install the rocker shafts. I've checked the rockers and have everything ready. Now I'll check the push rods. Rockers, mine are tightened. Next I'll be adjusting the valves. To adjust the valves, I need the first cylinder. Here is our first cylinder. Bring the piston to top dead center on the compression stroke, not the exhaust stroke. So for this, I turn the crankshaft clockwise until the intake valve operates, and after the intake valve has operated, I catch top dead center on this cylinder. Top dead center. You can catch it by the injector, by the piston, you can catch it by the flywheel or by the degrees. So as you can see, my mark that I made for installing the pump, I still need to turn it a little more. You can see that I almost got it to 0. Top dead center. But still, I think now I'll do it, as I'm about to put the pulley on. I didn't put the pulley on before because I didn't have the rubber gasket for the plug. Now I'll put this plug in place and then install the pulley. And I'll make my marks on the pulley itself. Well, this isn't a mandatory procedure, but that's how I do it. Sometimes it helps. Here the plug looks like this. It's also a bit damaged, corroded. Well, here's a new rubber gasket. Now, I'll put on the new gasket and coat it with sealant and everything will be fine. With the plug in place, it's time to install the indicator. All the pulleys are tightened. Now I'll make marks on it. It's showing 0 now. I'll set it to 14 degrees for installing the fuel injection pump. This is my top dead center. First cylinder number 3 is at the compression stroke. Now I can adjust the valves. Here I have top dead center compression, and in this order I can adjust the first, second, fourth, fifth, and so on. That is the first, second, fourth, fifth, and so on. So the first cylinder is adjusted and so on. I won't record everything. I've adjusted all the valves, set the ignition marks. I'll set it to 14 degrees, but there it's 12, 14, plus or minus. That's all for the clearances. I'll see how it turns out in the area. In this range, I'll set it from 12 to 14. So I'll also make a 14 degree mark on the pulley. These marks aren't necessary, I'm just putting them for clarity, for the video. Well, sometimes these marks actually help out in the pit. That is, if you need to check the ignition, you don't have to crawl around in the dirty pit. Somewhere around here I checked, and I'll also put a mark on the camshaft to show that this is my top dead center. Alright, compression too, it's not really unnecessary here, sometimes it's actually needed. When setting the ignition or pump, you may not remove the valve cover to check if it's compression or exhaust, so having it here is beneficial. If someone knows, they can tell just by the video, the owner may need it later. He'll just look at the camshaft, and if there's this mark, it's top dead center on the first cylinder during the compression stroke. That is, it's exactly for installing the fuel pump. I've finished with the pulley and valves. Next, I'll install the injectors and fuel pump. Currently, I'm installing new washers, injectors, and nuts. So first I'm installing the washers. The injectors are now in position, which is typical at this stage. It's smaller, all of that is stuck there. Pouring oil right there into the thread. With the injector already installed, I pour more oil in there. I do the same with all the injectors. Now I'm installing the fuel pump. I've already set the timing marks, top dead center is at 14 degrees. And that's it, now I can install the pump, meaning the engine is already set up. Here, of course, all the threads were cleaned with a tap. Everywhere, I mean all of these, well, all the threads, absolutely all the threads on all the blocks were cleaned with a tap. I took out a lot of dirt and sealant from there and so on. The pump needs repair because of corrosion. That is, the plugs were just hammered in a little deeper, and in principle everything turned out well. Here it protrudes a couple of millimeters, so there are no issues, everything is okay. So, next I put a new rubber gasket on with super glue and put on this sealing ring as well, the big one, also new. So, what else do I want to show? Now I'll show the condition of the gear. There's not a single mark from pliers or a vise, meaning the gear wasn't clamped in a vise, so you can do it? Yes, you can. Last time I had a video, last time I showed how this gear is clamped in a vise, what condition the teeth are in afterward, how they get deformed and so on. So next I put the mark and install the pump, aligning the movable and fixed marks. And now I'll also unscrew these 3 lower bolts just in case, if I have any misalignment, so that I can fine-tune the ignition adjustment. As usual, I applied sealant to the mounting surface. I tightened the pump and the marks haven't shifted. The bolts were loosened for nothing. Now I'm tightening these bolts and the pump is installed. Everything is good. Alright, the pump is tightened. I marked these bolts. Every bolt that I tightened I marked so I wouldn't miss anything. Next, I'll immediately close this cover so that nothing else can fall inside. I'll close it right away and that's it. I applied the sealant and I'm putting on the gasket, the tongue. Next I will install the valve covers. I ground the surface on a machine. It was a bit warped, but I fixed it. I checked it on a plate. Everything is perfectly flat. Now I take the gasket and install it. All the valves and covers are in place. This cover isn't original, it's from the 400 series. Covers from that series had this type of casting. I don't know why it's not the original one, but alright, let it be as it is. So, when I was taking it apart, I noticed that there's something strange going on here with the water pipes. Everything was done in an unclear manner here, in terms of what, how, and why. You can see that the cylinder here was minning, and as far as I can tell, this pipe was resting against the block at this spot. It was pressing against the head like this, and you can see that they tried to tighten it in every possible way. They wrapped it with polytetrafluoroethylene tape and something else, but apparently it was still leaking here, because this was done incorrectly. I just ran into this now, and I thought, how am I supposed to put all of this back together? So I decided to remove the air-cooled cylinder and install a water-cooled cylinder instead. The supply will also go from the top through the head and the output will be from here. Here I have the original tube that should be installed here. This is how it will be positioned and the supplies will be connected. Already, I'm currently reworking the cylinder just like that and that's it. So I replaced the cylinder, installed a water-cooled one. Now it will be more reliable, better, and I also put in the tube that should be there. Here, nothing gets in the way, nothing interferes, there's no need to cut anything. So, next I'm installing the head, closing the tube cover, but I'm assembling everything very tightly up here. Now I need to unscrew this fitting and put in a plug. Alright, that's it. I unscrewed the fitting and put in the plug. That's all. Now I'm installing the head in place. So I'm installing the upper tube. I'm leaving it unchanged just as it was. The head is installed. The tubes are not installed. Next, I'm installing the hose back. I'm cutting pieces like this, 25 centimeters each. I'm leaving these hoses longer, they're going to go right here. Near the return line to the pump, 2 plugs are installed. The return line is now in place and the air manifolds can be fitted. The electric parts were cleaned internally, removing all the dust. This is their current appearance. Okay, so now we're back to the air manifolds. Let me show you what's missing there. There was a moment in the last episode during disassembly where people wrote in the comments that it's not dust but soot that settled on the walls. I want to show exactly where it was taking in dust. The air hose, and right here it just delaminated. Look at this hole. I'll put a flashlight there now so you can see it better. It's easier for it to take in the air here as much as it can, rather than pulling it through and overcoming the resistance of the air filter. That's why there was dust in the air manifold, because of this hose, because of the crack, that's all. I wanted to film it, but I kept forgetting. So, accordingly, this pipe needs to be replaced. Then I need to install this bracket. I put in new rubber seals here, smeared it with sealant, and I'm installing it. Next, I'm installing the pump. I didn't overhaul the pump because it was replaced with a new one 6 months ago, so I just washed it, cleaned it, and now I'm installing it. Next, I'm installing the oil filter housing. I put in new gaskets, new rubber seals, applied a bit of sealant, and prepared the washers. And right away I'm installing the new filters. So I immediately connected the fittings, put all the hoses in place, installed new washers and tightened everything up. For now, the return line is loosely attached. Later, when everything's in place, I'll check and possibly trim it shorter. That's it. Now I'm installing the nozzle. I set everything up like this, tightened it after I connected this hose. Maybe it will turn a little to the right or left. Alright, next I'm installing the jumper between the air manifolds. Next, I'll be installing the high pressure fuel lines. Alright, next I'll be working on the turbines. The turbines were sent for testing on the stand. They checked them on the stand and said that everything's fine with them. They don't leak oil, which is the most crucial aspect. But when I took them apart, you could see there was dry dust, but there was no oil, so that's good. They just cleaned it, sandblasted it, and that's it, so they could remove the studs somewhere. Now I'm going to take a look. So I have these repair kits for the turbo. I'm also going to check what's inside them now. I see studs, nuts, gaskets, and more. I've cleaned the manifold a bit here. Now I'm going to blow them out and install the turbos. Let's go. So we can see that on one turbo the studs were unscrewed, but on the other they weren't removed. But I probably won't do that either. It's unclear how to install it here. Alright, let me check. There was a knot on this thread, you can just cut it off. It's pointless to touch them now, you'll only damage them, making it impossible to unscrew these things. Alright, I'll try to check and assemble it now. Let's see how it turns out. I've screwed in all the studs. Sorted out which turbine I have and where it's from. I only replaced one stud here because the nut fits just right up to here. The thread here is fine. I've prepared these flanges. I don't know, they cut it here when they were removing it. Well, it'll probably leak a bit here, but I've prepared the flange so I trimmed it a little. Everything here was covered in corrosion. I've also prepared the manifolds, cleaned everything, and chased the threads here as well. The studs are still good. What do I need to do next? I need to replace all these seals. These ones are for the oil drain and these seals are for the air. They go to the air supply in the manifolds. I need to clean here first, I'll do it now. Next I'm installing the exhaust manifolds. I installed the bracket. As I understand it, the air conditioner compressor is mounted on it together with the engine. It's standing just on the mounts. And what's most interesting is that when I was unscrewing it, there were only these two bolts here and this one bolt right here. And even then it was a short one. I replaced it with a long one. I don't know, maybe when they were taking it off, they unscrewed them, but these bolts right here, 1, 2, 3, 4, 5, 6, these ones. There wasn't a single bolt. I don't know. I screwed them in, found 6 bolts at my place, screwed them in, and that's how it went on. I immediately installed the cushion, a new cushion. I installed it right away. I'm not tightening it yet because I'll need to align these studs with the holes on site. I installed the gasket inside the manifold, applied special assembly paste, replaced this drain rubber, but I'm not tightening it yet. Here I also fitted this drain channel. I'm installing the turbine. Next, I'll be installing the second turbine. I installed the turbine. Everything is tightened and fits well. It's all in place. This is the drain from one turbine. Everything fit well. This is the drain from the second turbine. The turbine is in place. I installed this air manifold. It's also cleaned inside. I also installed this pipe for air intake on the compressor. I found a threaded corner piece here. Unsure of how it got here or who left it. I replaced it with a simple old corner piece I had without threads. The pipe bends slightly here. There should be a 45-degree angle, or perhaps there was previously just a tube in this location. So I'll just leave it like this. I can't think of any other solution anyway. I tighten these clamps, I tighten these bolts that hold this pipe and the ones that hold the loop used to lift the engine. Moving on. Now I'm installing the oil supply. To the turbines, here one pipe goes here and the second one goes here. The second pipe is attached to the first one with this kind of bolt. It's a unique bolt that functions as both a regular bolt, securing one pipe, and a fitting, allowing a second pipe to be screwed on top. That's quite an interesting part. Alright, so the turbines are fully installed, everything is tightened, the turbines themselves are tightened, the drain, the oil, everything is connected. For now, I positioned this cut pipe, added new studs, and loosely attached new nuts without tightening them yet. Now I'm installing this big pipe. All I have left is the pump, dipstick, small parts, starter, and mounts. The engine, you could say, is assembled now. This is how it looks at the moment. Now I'll also bolt on the mount, one new one, and basically that's it. For now, I'm not tightening it yet either. So that I can align it on the spot, move it around to get it into the hole and then tighten it in place. My engine is ready. I'll close it up now. What's the next step? Now I'm going to close it up, seal the holes, connect the diesel, connect the starter and the batteries, so I'll be getting it ready to start. The startup will be a separate episode for me. As for painting, I don't know yet if there will be painting or not. Maybe there won't be any painting. Next, there was a question about the cost in the comments. You wrote to me there asking me to mention the cost of the work, spare parts and so on. So now I'll briefly tell you. In total, about 350,000 was spent on this engine. That is, I don't have exact accounting, but I'll share the information I know. First of all, I'll say that it turned out the repair happened at not the best time. Right now, when it's a better time, the dollar rate was 63 and then it became, I don't know, 75 or something like that. So this, of course, also affected the cost of spare parts. The piston group was the costliest part for this engine, costing around 100,000 rubles. Excluding the piston group, around 130,000 rubles were spent on the remaining spare parts approximately. Also, this 350,000 includes a complete pump overhaul. The pump repair cost about 50,000 rubles. Basically, that's not so expensive. Up to 50,000 is a large amount. But, let's say, if you take a fuel pump for a 442 engine with an electric throttle, even just repairing one pump there can cost as much as 2,000. What other work was done? For example, we sent the cylinder heads for grinding, we sent the connecting rods to be machined, so the heads and the rods alone cost about 10,000 rubles, maybe more. Then we sent the turbines for inspection plus some kind of repair as well. They sandblasted or inspected them, that's also about 10,000 rubles and so on. So all of this adds up, accumulates, and you end up with this kind of amount plus this engine. Okay, if they just brought it to my workshop already removed. This amount of 350,000 includes all these jobs, removal, installation, my work on overhauling the engine, the labor. We outsourced the cylinder heads, pump, turbines, and other components to third-party organizations. The most expensive spare part is the piston assembly, costing over 100,000 rubles. All other parts cost around 100 to 130,000 rubles. All the other spare parts for the entire engine, including compressor repairs and so on. In your comments, you also said there's no point fixing this engine and that buying a contract one would be easier. I agree to an extent. That much money could buy a contract engine. But again, it's still a question of what kind of engine it is and what condition it will be in. If you have a reliable supplier who guarantees that this engine will last for you, if you find such a supplier who will sell it to you with a warranty, then why not? Of course it happens. Sometimes people write to me and tell me how they bought contract engines, and it turns out, for example, that it comes without attachments, without a compressor, or missing something else. And then they also start assembling all of this themselves and they consult with me on how to do it. There have been engines that consumed oil, so they had to replace the pistons and so on. In any case, an old engine is a pig in a poke, so I don't say anything. I have nothing against contract engines. It's just a gamble, a pig in a poke. That's my view. One person will have a great experience with their purchase, while another will deeply regret their decision. That's why this question is so controversial. One person wrote that he bought a contract engine at some auction. He bought a contract engine from Japan, also a 442 an engine for 350,000. He bought it. This engine has either 8,000 or 18,000 kilometers on it. Yeah, that happens. He bought it from a fire truck with a ladder, so it's clear what kind of mileage it has. The guy lucked out. Getting an engine like that for $350 is like getting a brand new one that'll run forever. That's why there's no clear answer here, whether to repair, not repair, or buy a contract engine. You can repair it, you can buy one, or you could just send your money and end up with neither an engine nor anything else. There have been such cases, so it's a really tough question that everyone must decide for themselves. Next, I'm installing the transmission. I shift into gear. The input shaft splines are already installed into the disc. Now I need to secure it. So the gearbox is installed, I've tightened all the bolts, now I can disengage the gear. Now I need to get the release bearing into the clutch basket. So I press the release bearing with a pry bar like this, and now I need to fasten the pin. Here it is, this pin, and it will act as a stopper for me. It will secure it now. The release bearing, and now it will only move together with the clutch forks. That's it, I've fastened it. Now the release bearing can't be separated from the clutch forks anymore. You can see that the release bearing is secured. Okay, now I need to close this small upper inspection cover. The gearbox is installed, the release bearing is fastened. Now I'll start preparing the engine for installation into the bus. Okay, well, I also need to install new mounts. So I'll unpack them now, just put them in place. I won't tighten them yet. They will be tightened later, on site, on the vehicle. So now my task is to put it on a wooden pallet, set it up, and that's it. After that, it will be installed on the vehicle. So we can see that the engine is already installed on the bus. This is how it looks. It looks